good afternoon, everybody, depending on your geography. Thank you very much for joining this webinar. This webinar is under the umbrella of the project PAOLA, which stands for the Pandora Box of Whistleblowing in Academia. And we have today with us, and thank you very much, Professor Montoliu, for accepting and making this experience of learning of our community better and more aware of the ethical issues. And the focus of the current webinar is on advancing integrity in academia. Before we start, I would like just to briefly explain the structure. We start with a small introduction of the speaker. Then we give the floor to the speaker, and the final 10 to 15 minutes we have for questions and clarifications. During the presentation, I will kindly ask the participants to turn off your microphones, and if you have urgent questions that you're afraid to forget, you can use the chat channel to text them, or if you can raise them, and at the end when we'll open the floor for the debates, discussions, and the comments that I am sure that our distinguished speaker will raise many interesting aspects. Now, this being said, I would like now to pass to the first part, which is the introduction of our distinguished Professor Lluis Montoliu, who holds a degree and a PhD in biology from the University of Barcelona. He is a researcher at the Superior Council for Scientific Research and a member of the steering committee of the Center for Biomedical Research Network of Rare Diseases at the National Center for Biotechnology in Madrid, where he also is currently the vice director. He has been for more than 20 years an honorary professor at the Autonomous University of Madrid, and he is currently honorary professor at the Complutense University of Madrid at the Faculty of Biology. He has been a member and the president of the ethics committees and of the Superior Council for Scientific Research, and advisor to the Superior Council for Scientific Research presidency. Also to the Science Europe advisor on ethical issues. He is also a member of the ethics panels of the ERC in Brussels. Apart from his academic experience and dedication, as we can see, the ethics have been an important part of these activities. He also has founded and chaired several scientific societies. Among these, which he is currently chairing the European Society for Pigment Cell Research and International Federation of Pigment Cell Society. He is a vice president of the Association for Responsible Research and Innovation in Gene Editing, and is scientific secretary of Spanish Society of Biochemistry and Molecular Biology. This being said, I would like to thank again Professor Montoliu for accepting and finding time in his busy schedule to join us today. And now I give the floor to you, Professor, for your presentation. Thank you very much, and we are looking forward to hear you.
Thank you, Mariana. Thank you for a very kind presentation. It's my pleasure to be here with you. And also I congratulate you for leading this European project on this very important matter. And it is fundamental that starting from young researchers like Marie Curie fellows to deal with this research integrity. Without further delay, let me share the presentation, and let me confirm that you see everything all right. Okay, so this is advancing integrity in academia, and basically I will be talking about research integrity. Well, let me tell you right away that research integrity is the elephant in the room. So it is this big animal that if you don't pay attention to it, it will continue breaking chairs and tables, and it will destroy your laboratory if you don't follow the guidelines, if you don't, because all of us, all our labs are exposed to danger, are exposed to risk, are exposed to research misconduct. This is unavoidable. We are human beings, and therefore there will be always people trying to find shortcuts. The importance of these situations is to recognize them as soon as possible, to denounce them as soon as possible, and try to make and to reach a solution as soon as possible. Because otherwise, this will be detrimental for the science and for how you will be living in that laboratory. So basically, research integrity is this battle between the angel and the devil. The angel saying, don't cheat, don't fabricate, don't lie, follow the rules. And the devil saying, please copy, fabricate, cheat, and don't follow the rules. So basically, this is basically what we are facing. We shouldn't forget that speaking on the liberty, on the liberty in the academia and the freedom in the academia, so this shouldn't be misunderstood. This shouldn't be misunderstood with the fact that there is a framework that delineates what you can do in science. Basically, inside this red rectangle, it says, it states all the different actions that you can do in science. And outside this rectangle is what you shouldn't be doing and we cannot do. And it is important, it is fundamental, it is instrumental to know that we should know that we have limits. Of course, we have limits, and this is important to know. So the research integrity is, as it says here in this document from Science Europe, it is at the core of the research. It's the basis by which we can trust each other. So we trust each other because we believe that what we are publishing, what we are communicating, it's true science, and we're contributing to the research record. The responsibility that we convey when we are transmitting things that are not appropriate, things that are not right, things that are invented, things that are wrong, is that we are not only altering this trust, but also we are altering this research record. So we are altering this research evidence and expertise that the society has and believes that we have. So we basically cheating on the society's trust. We shouldn't forget that whenever we're publishing things that are not right, things that are invented, things that have been manipulated, we're not only committing a mistake and we're not only committing research misconduct, but we are altering and we will be affecting the research that will be coming later on from people that will be basing their projects on our wrong messages about our wrong information. Of course, research integrity is about honesty, accuracy, efficiency, and objectivity. And basically, we can focus on the research integrity in two main aspects that I will be discussing over the rest of my webinar. First, we need codes, we need guidelines. So this is a discipline. Research integrity is a discipline, and we should not be expecting that just people know for granted about this. So the same way that we have to learn the rules where to escape from our building when there is a fire, and we have to learn the rules what to do if there is some toxic spillover in our labs. We also need to know how to behave in the lab regarding our research conduct. There are codes and there are guidelines that we need to study, that we need to know that there are, and we need to just to make them make them part of our scientific life. This is regarding codes and guidelines. And the second aspect I will be discussing here is regarding credibility. And credibility in science depends on two aspects. First, on the quality of the research that we're doing, and on the reproducibility of our results. There are many documents that you can use in order to progress into your understanding and to be familiar with the different angles and aspects of research integrity. This is a manual that was produced by the National Academy of Science in the US on being a scientist. There is a third edition from 2009. Then we have this 203 Introduction to the Responsible Conduct of Research from the Office of Research Integrity in the US, which is also a very interesting document. And of course, being in Europe and being a depository, and I believe this is a webinar that is primarily addressed to MCSCA fellows, when we are accepting public European money, we are confirming, we are supporting the European Code of Conduct for Research Integrity. And you should know that there is this novel edition that was published, that was issued in July 2023, that has been translated in all European languages. So you can find this the same code in all your different languages, and I strongly recommend reading it. It is short, it is concise, it is very well prepared. And Science Europe, in which I was also participating, we also took part on the preparation of this book. So these principles that are the overarching principles on this code are these four concepts on, again, reliability, honesty, respect, and accountability. There are different codes, and no matter, irrespective of which institution you will be working, the first thing you should be asking around is whether your university, your research center, your laboratory, the place where you are developing your research has already their own codes for good scientific practices. Over the pandemic, I happen to be the chair of the ethics committee of our institution, the CSIC. That's the Spanish National Research Council. That's our largest governmental-based research institution. There's more than 15,000 of researchers all across Spain, and we updated our previously existing code for good scientific practices, and it is available. Basically, you can use this QR code and you will be brought directly into. This is also published in Spanish and English, and this is by no means this is the a code that should be an example. If you need a code to be following, and if your institution doesn't have a code, my recommendation is that you adhere to the European code. In this code, in this institutional code, you will see that mainly we follow the dictates of the European code with some peculiarities from our institution. Across the different countries, they have different levels of implication regarding research integrity. We started in our country in 2015 with a national declaration on research integrity that was subscribed by the different scientific societies, the different universities, and our research institution. And very recently, and as recently as November 2023, we had our first committee that the mandate of this committee, the committee is the Spanish Committee on Research Ethics, is to promote, to establish guidelines and to oversee research integrity in Spain. You will see that there are no standard model across the entire Europe, and this is already perhaps a bit old report from ENRIO. ENRIO is the European Network for Research Integrity Offices, and there are some things that might have changed, but this is just to illustrate that there are different models how to promote and review ethics, scientific integrity. From those countries which they have an established national framework and they have a law, and the law that basically is ruling how you will be governing this ethics, scientific integrity, to other countries in which there is no guidelines, there are no governmental mandates on ethics integrity. Ideally, I would love to see all these countries in color, in purple color, which would mean that all have already established laws that regulate, that tell you how to deal with this scientific integrity. What I recommend you is to visit the updated pages of NRIO, and in the updated pages there is this very interesting information in which you can choose the country where you are performing your research, and you can query how this research misconduct, how research integrity is being addressed in the country where you are doing your research. Of course, we are miles away. We are years away from what has been done in other countries, such as in the US. In the US, the homologous office, the homologous committee, is the US Office of Research Integrity. And there are many differences between this committee in the US and the committees that you can find here across Europe. And perhaps the main and most important difference is that all our committees in Europe, they tend to be consultative. So we are not executing. We are recommending, we are preparing reports, and we're sending these reports to the authority of the university, to the authority, to the chair, to the president of the research institution. And these are the people that they are taking decisions. Whereas in the US, this ORI, this Office of Research Integrity, they are capable of adopting decisions. They are capable of putting fees and penalties and sending people to prison if they feel that they have committed very severe research misconduct. And they do something that normally we don't do here in Europe. They publish regularly the names of the scientists that have been investigated and found to be associated with research misconduct. These are people that have breached research integrity, and you can click on each one of these names. For instance, I chose just for an example, I chose Richard Ecker in 2024. And if I click on this, what I will see is that this person has been found to be intentionally, knowingly, or recklessly falsifying and fabricating data in 13 published papers and in 2 grant applications. So you can detail and you can find exactly what this person has been committing on the breach of research integrity. Unfortunately, this is not the type of information that we are used to have in Europe, and this is very important when we are about to hire new researchers in our universities, in our research centers, because this is a place where in the US, every institution, they will be double checking whether the person that they will be hiring, it is not or it is in this list. This is regarding codes and regarding committees. What about regarding reproducibility? Well, you probably remember, or you might have seen this cover from The Economist in 2013. This is already 12 years ago, but I think still valid. So basically, this publication, this journal was putting the accent, was alerting about the problems that are associated with our research activity. And basically, it was referring to something that was later on developed from Nature. And Nature was preparing this survey in which they were contacting about 1,600 researchers, and they were asking whether, in their opinion, there was or there wasn't a reproducibility crisis. And as you can see, there is as many as 90% of researchers that they believe that there is a significant or slight crisis. And there is only a 10% of people that they believe there is no crisis, or basically they don't know what to answer. So we do have a problem when 90% of our population says we have a reproducibility crisis. What do I mean by reproducibility crisis? Well, people might think that reproducibility refers to being unable to reproduce the results from other researchers. You read a paper and you try to reproduce the experiments that are there described, and you realize that you cannot get the same results. Well, this is one aspect. But even worse is trying to reproduce your own results that you have published maybe 10 years ago. There are new people in your lab, and then these new people, in order to progress in science, they decide to challenge and they decide to reproduce what others have published in your own lab, and they fail. They cannot. So, and this is not something that is only associated with life sciences. While you might think that this is only related to medicine and to biology, well, this is not true. It is across all disciplines: chemistry, physics, engineering, health and environment, biology, medicine, and others. And if you ask what are the factors that are contributing the most to this failure or reproducibility, number one is selective reporting. Selective reporting, I'm only reporting things that support my hypothesis, and I neglect and I discard all the results that they are not supporting my hypothesis. And this is absolutely terrible. This is probably the biggest mistake and the biggest danger that we have in science. This is what is called cherry picking. I'm only collecting the things that I'm interested. I'm no longer collecting things that are contradicting and are challenging my hypothesis. And this is more extended than you might even imagine. Because, for instance, if I ask you which one of these two graphs you would prefer, you have on your left a difference between a control and an experimental series of data that happen not to be statistically significant, the differences, because the P is 0.150. So this is a negative result. You cannot confirm that there is a statistical difference between your control and your experimental data. Whereas in the right graph, you have pretty much the same results, but all of a sudden, the difference have become statistically significant because you have a P which is 0.015. You can put your first asterisk, and this is probably figure number one of your paper or figure number one of your PhD. What are the difference between these different sets of data? Well, these are almost identical data, with the exception that you have removed in the right graph, you have removed an outlier. And upon removing this outlier, you have turned something that was not statistically significant in something that is now statistically significant. So you're cheating yourself. You're cheating the science. And of course, when this is happening, and I repeat, this is more frequent than you really can imagine. When you remove such data, you even find excuses and you find an explanation to convince yourself, because you say, this is that point that I was spending more time because I received a phone call from my mother and I spent 2 minutes on the phone, and then the tube, it was overreacted, and then probably it was wrong. So I will remove this tube. And then all of a sudden, I remove this single data, and then the difference becomes statistically significant. So be careful. Whenever you have the situation on your left, it is telling you that the variability of your results does not confirm the statistical differences that you would like to find, because probably there are no statistical differences. And if you believe that this is something that is wrong, you believe that there must be some difference, what you could do is, instead of removing outliers, increase the number of data, increase the number of samples, and try to ask again the same. And if you are unable to find differences because they are known, and this is part of the science. So part of the science is not always finding positive results. Negative results are equally important. Of course, there are always people interested in publishing whatever you produce, and they don't care whether this is statistically significant, whether you have cheated or whether you don't have cheated. And this is the associated problem we're dealing in science nowadays. We have these predatory journals and predatory publishers that basically they're only interested in getting your money. So you just pay us $2,500 or 2,500 euros, and we will publish your report, we will publish your paper, and we will not care what are you including in this paper. There are lists in which you can check, and there are publishers and there are journals. This is evolving. This is one of the latest lists. This web is frequently down because there is always legal issues with publishers and journals. So sometimes this web is not accessible, but you should be aware that there are publications whose quality, irrespective of the impact factor, irrespective of how they are being announced, you have to be careful where to choose. You have to first inspect on the quality of the journal you're going to be using to publish your research before you decide to submit your research. Why is wrong this research misconduct? Because it's adding wrong or useless results, because we're wasting resources, because we are reducing public trust, because we're endangering public funding, because we might be endangering people's lives, and because we could be negatively impacted on policy and legislations. This is, I believe, one of my best examples to tell you the responsibility that we are carrying when we are publishing things that are not correct, things that are wrong, things that have been manipulated. These are four very top journals, before top publications that were in New England Journal of Medicine, Science, Lancet, and Plant Journal. These are different fields. It is noted the year in which they were published, 13, 2005, 98, 2003, and the year in which these papers were retracted. And I want to fix your attention in the citations, because the citations before retraction were some, I mean, this is variable, the number, but what is more important and more worrying, at least from my point of view, is the citations today. Well, today, these are numbers I calculated in May last year, but basically now we will have higher numbers. So please focus on the second paper. There were 228 citations before retraction, but after retractions, there are almost 2,000. This 10 times more citations. It means that the paper has been retracted, but it hasn't been banished from the scientific literature. And people that are not reading the papers, but are citing papers because previous papers have also cited that particular article, they will notice, and they will perpetuate, and they will be reiterating this mistake, because basically we are continuous citing research that shouldn't be cited any longer. So this is the responsibility that is associated when you are publishing something wrong and it gets eventually retracted. Well, there are very well-known papers. The Lancet paper, of course, that was this absolutely irresponsible and imprudent paper that was associated vaccinations with autism, that has been found unjustified, false, and imprudent, that was retracted. But nonetheless, the anti-vax collectives, the people that are against vaccination, they're still using this publication just to continue their campaign, this absolutely unjustified campaign. What about the pandemic? Well, there is more than 400,000 papers published on COVID-19. And this is something I double-checked this morning in Retraction Watch. There's more than 469 papers that have been retracted on this topic. Well, you might think that this is a small or a big number. This is about 0.1%, 1 in 1,000 of the papers retracted. I think this is an absolutely unacceptable number. This is absolutely large number. There are more than 400 papers that they have been distributing false signs, that they have been distributing cheating experiments, that they have committing research misconduct, including that particular paper that you might remember from March 2020 from some French immunologists in Marseille, in which they wanted to put forward the idea that hydroxychloroquine was useful to treat COVID-19. They were cheating to begin with this graphic. In this graphic, they were comparing apparently some untreated people with people treated with this drug and people treated with the drug and an antibiotic. You might think how many hundreds of people were included in each one of these series. This is the figure how it was published. Then I was looking for the people inside each one of these cohorts. And for the controls, they claimed there were 16, but they didn't have data from 12. So basically they have 4 people. And for the treatment with hydroxychloroquine, they only have 14 patients, and together with an antibiotic, they only have 6 patients. Do you really believe you can confirm or you can conclude anything with these absolutely small numbers? And also, where are the error bars? Where is the error bar in this graph? Well, this would be only small paper that we shouldn't be paying too much attention unless we realize that this was the paper that was picked by the President of the United States and the President of Brazil, and they were using this paper to be alerting and announcing the use of hydroxychloroquine. And that was absolutely imprudent because they were basically collecting and removing all the stocks of this drug that is, by the way, used to treat autoimmune diseases. And this was absolutely unacceptable. Eventually, this was in December, at the end of last year, in 26th of December, that was eventually retracted. It took almost 4 years to retract this paper that was creating a lot of problems. There were also papers in Lancet and New England Journal of Medicines that were also discussing the use of hydroxychloroquine that they had to be retracted. So what is the research misconduct? Well, these are behaviors that compromise the proper professional conduct and alter the accuracy of the research record. So we are always referring about falsification, fabrication, and plagiarism. These are the main causes of research misconduct. We will see now immediately that there are other aspects that should also be included in research misconduct. So basically the message is do not lie, do not cheat, do not steal. One might think that deciding whether a case is associated with research misconduct or not, it is something very easy. You might think that an experiment maybe it's correctly done or incorrectly done, and you might think that this is about deciding between black and white. Well, if that was the case, the ethics committees will not be needed. But this is unfortunately not the case. You might think, well, we have to condemn, we have to discard, and we have to spot all image manipulations. What about these 2 images? These are my mice, a picture I took some years ago. I'm using animal models for human diseases research. And if you compare the 2 pictures, you will see there is one difference, and the difference being there are some feces from these mice on the left that have been removed with Photoshop. Well, this is for statistical purposes. I can tell this at the legend of the picture Do you think I have altered the research record? I did not. I did not, because the mice are the same. I'm only showing this in a aesthetically different manner, but I have not altered the scientific message of the picture. And this is totally different from if I try to remove one mouse, because all of a sudden I realize that this one mouse shouldn't be this. And then I'm trying to use Photoshop, and more or less I try to convince the people that instead the original picture had only 5 mice and not 6. Well, this is clearly an image manipulation. This is research misconduct. The first was not research misconduct. The same goes with when we're comparing images that they are pretended to be different, and in reality, they're basically flipping around, and basically we're dealing with the same image that has been presented in different orientations. Sometimes we are presenting data with less variability than there is, because we want to show that we are publishing robust sciences, robust conclusions. So if you compare the left graph with the right graph, you probably will decide together with me that the right graph is more appealing because the error bars are smaller. Well, they are smaller because on the right we are measuring the mean plus minus standard error of the mean, whereas on the left is mean plus minus standard deviation. And of course, we know that the standard error of the mean is equal to the standard deviation divided by the square root of the number of samples. Therefore, the sum, the standard error of the mean, will be always smaller. But of course, what we shouldn't be doing is using the sum and pretending and letting the reader know that we will be using standard deviation. If we use the standard error of the mean, we have to declare this is the standard error of the mean, and plus we have to provide the number of samples in each series, because then the reader can calculate the standard deviation properly. Therefore, there is a gray territory, so we have always to inspect and evaluate the different aspects. So basically what we say in research ethics and in integrity is that every case is different and we have to progress case by case. So what about plagiarism? Here we have 2 papers apparently with different authors, it's in different journals. But if you approach your eyes to the screen, you will see that the text is exactly the same, with the exception of 2 words. There's only 1 word in the title that has been changed. So this is a phenocopy. They have been copied almost 100% with the exception of this. Well, this is clear, a case of plagiarism. But plagiarism can also be self-plagiarism. You copying yourself. And this is something more frequent that you might imagine as well, because very often we are pressing in time and we are running short in time. We have to submit an abstract to a meeting and we prepare a short text. 6 months later, we have to submit another abstract to another meeting. We're short in time. We didn't find the time to prepare a new abstract, and we decide to submit to the second Congress the same abstract we submitted for the first Congress. Well, then we're cheating. We're cheating. This is research misconduct. We are self-copying because we are letting the people attending the second Congress to realize that this was this was a pioneer research. And in reality, this is a research that has been already presented 6 months ago into another meeting, into another Congress. When you ask around whether plagiarism is a problem, most researchers, they will say 30% of people surrounding me, they're doing plagiarism. They are plagiarizing research. But then when people is asking about you, what about you? Are you self-plagiarizing? Are you applying this plagiarism in your research? Then self-admitted is less than 2%. Of course, This cannot be. So you cannot have 30% on one aspect and only 2% in the other aspect. But this is already telling you that we have a problem that we have to deal with. Where do we have an impact in this research misconduct? Well, everything in all the different aspects of the research process. From the beginning, when we're planning the experiments, when we're conducting the experiments, when we're interpreting the results, when we're publishing the results, and even when we're reviewing the results. I'm reviewing the paper from a friend, and I'm going to be very soft, and I will be recommending publication. I'm reviewing a paper from an enemy or competitor, then I will try to spot as many problems and as many differences or as many difficulties, and I will be recommending doing so many experiments only for delaying the publication. In both cases, whether we are supporting on whether we are interfering with the publications, we are committing research misconduct. Why this is wrong? Well, of course it's wrong, but why in reality is wrong? Because we can have consequences for individuals. We might be losing the prestige, we might be losing our job, we will be exposed to the discredit by our colleagues, we might be entering into depression. And in the US, remember, these are executive officers, we might be sent to the prison, or we might be obliged to pay monetary fines. This is the difference between Europe and America, and Europe and the US. Here we have one clear case of research misconduct. This is Olivier Poignette, an applied scientist working in France and in Switzerland, with so many cases of papers corrected and retracted. Well, he's still in science and still continue publication and is still doing research after some investigations and having been clean after a final investigation in their institution. Whereas in the US, we have another researcher, Dong-Pyu Han, that was claiming to have found a vaccine for HIV, and that was absolutely an invention. That was not true. He was sent to 5 years into prison, and he was asked to refund $7 million that he had received from NIH. So you see the difference between how do we deal with the research integrity in Europe and the US. And I'm only presenting this. I'm not suggesting that in Europe we have to follow the US model. I'm only telling you that in the US the consequences are more extreme than in Europe. And in Europe you can commit research integrity, and sooner or later you're back into the system and you're back getting money and you're back publishing against science, which might not be well understood by the society. There are cases, well-known cases of frauds, such as the Wushu Kwang, that was claiming to have cloned human embryos, that was totally invented. There were 2 papers in Science, how these were retracted, why this person had this credibility, because this person had cloned the dog following Dolly the sheep. He had cloned the dog and he gained credibility, and he was using this credibility to publish these other irreproducible papers. Nowadays, this person has reinvented himself, and he's cloning pets for people that they want to spend $10,000, $20,000, $30,000 to try to get a clone of their pet that has passed away. No, you can learn about this case. There is a very good documentary in Netflix. It's called King of Clones. I really strongly recommend, because you will see research misconduct being presented. We have another case, which is Haruko Bokata. That's years later. That's about 11 years ago. She was claiming to have found a system to convert any somatic cell into a pluripotent cell just by changing the pH of the cell culture media. Well, that was wrong. That was an invention. She was inventing these results, but she managed to publish not 1, but 2 Nature papers back to back in the same Nature issue. And that was totally wrong, and very soon it was found. Well, the consequences in this case, she had 3 supervisors, and one of them was he was not finding possible to continue living with this discredit, and he committed suicide. This is probably the strongest consequence of research misconduct. Yoshiki Sasai, one of the best research developmental biologists in the Kobe Center at the Riken in Japan, he was hanging himself at the door entry of the Kobe Center, and he was leaving a message to Haruko, please make sure your data are correct, and they are not correct. She was cheating, and this was unfortunately one of the very well-known cases. We have some tools for investigating what people is doing with research misconduct, and these tools, they have to be used very carefully. Retraction watch is basically reporting on things that have happened or things that might happen very soon, and they are collecting the papers that are constantly being retracted. PubPeer, it's an anonymous service in which anyone can present potential manipulations of data from a third person. Well, here the danger is that it is very easy to put the doubt and put the problem into a scientist that might not be a real manipulation. That might be perhaps a problem that can be easily interpreted and easily solved. In some of the cases, they are real manipulation, they are real falsifications, but in some of the cases, they might be not. So we have to use this very carefully because we might be altering, we might be compromising the prestige of people, probably maybe sometimes without any scientific evidences. Well, there are cases in which this is clear. So we're using the same blood for illustrating different proteins in different papers, in different journals, in different years. This is not a mistake. This is clearly using again the same image and reusing an image, recycling an images for a different purpose. Or here we are turning around one of these results pretending that these are different images when it is exactly the same image. So just reusing bands all across different experiments just to illustrate and to show what our hypothesis wants to show. Whenever there is one paper that is being found, often when we try to investigate, we will find that this person is not only committing research misconduct in that single paper, that instead this person might have a career of research misconduct. This is a case from a Spanish scientist that was found guilty of research misconduct in a cell cycle paper. But then when she was investigated, there were papers also manipulated from her PhD, from her postdoc, and also 2 more papers from her work as PI. So basically, this is what I consider a pathological behavior. People, they try to do a shortcut. If they succeed, they think, well, let's try it again. And if they succeed again, and they try it so many times until they lose control, and sooner or later they're spotted and you are revealing the entire career of alterations. What are the standard responses from people when people are found guilty? Well, to my knowledge, I have done nothing wrong. These are false, all these accusations. There is an easy explanation for each mistake. There could be an advertent mistake. I could easily replace the data, but I have lost the original data, or my computer just has been stolen. This is very common. It is ridiculous, but it is common. And what is even more common, what all the people that are following this webinar, they will not be able to use this excuse again, is that people are saying, I have received no education on research integrity and ethics. I didn't know I could not reuse figures. I did not know I could not improve figures. Well, this is wrong. This is what was used by Haruko in Riken, and this is why in Riken now, when there are new people entering, they are being instructed and they are receiving some formation on research ethics and research integrity. What about ghost authorship? All of a sudden, there are people that are listed as co-authors that do not correspond with existing human beings. So these are names that are used, that they are behind a Gmail address, perhaps. And this Gmail address, this is always sending results in support of the hypothesis. This was a case that was happening in Spain and that was affecting so many papers. Also, we have to pay attention to the co-responsibility when we are co-authors of a paper. We might have contributed only to the panel V of figure number 4, and we might only want to hold accountability for that figure that we have produced. Well, this is not correct. This is wrong. When you are listing yourself as a co-author of a paper, you are confirming you agree with the conclusions and with the entire set of data that is being presented in that paper. So you are co-responsible. So if you have some doubts, if you have some problems with some other people's data, what you need to do, you need to declare this, you need to request some information, you have to request explanations, and if the explanations that you receive are not convincing, what you have to do is you have to remove your name from the paper. If you stay as a co-author of the paper, you will be held co-responsible. You will be found co-responsible if that paper is ever spotted as research misconduct. Of course, you cannot use as primary an affiliation which is not the one that is paying your salary. If you are hired by a given university, you should not be pretending to be working for another university that wants to gain more prestige by paying some sums of money. And by doing this, they will be gaining some more additional publications, and they will be going up in these rankings. Well, this is also research misconduct. It is nothing wrong if you're working for more than one institution, but it should become clear what is your primary affiliation and what are your secondary, tertiary, and additional affiliations. Of course, you cannot boost citations artificially. You cannot build these cartels of people, whether they are existing or whether they are invented personalities or bots, that their only function is to cite and to refer to your own papers. And by doing this, you will be increasing your H index, you will be increasing your rankings in these different lists, but this is wrong. You shouldn't be doing this. Why do we have this? Well, because everyone wants to publish and succeed. This is about this issue about publish or perish. And because we have this very strong, which is absolutely unacceptable, but we need to admit that there is this extreme pressure to publish high impact journals. We have the willingness to be recognized, to be success. We might wish to access to the highest grants in Europe, the ERCs. And of course, in order to get an ERC, you need top journals. And you might think you have to do what you need to do in order to get into these journals. Well, we are human beings, therefore we are committing mistakes and we have temptation. But this is bad and criminal behavior. How to prevent this? Well, basically studying guidelines, doing checklists, writing everything in the protocol book, getting in touch with your institutional research integrity office or committee and transmitting them whenever you see something that is wrong around you. Training on research integrity, this is what we're doing today. And of course, mentoring and supervising. Because the mentors have the responsibility, they hold the responsibility of the entire lab, not only of their own selves, but also of the students they have in charge. Because these mentees, they might not know that some practices are wrong, and they might not know the consequences. And this is, for instance, what Olivier Wanet was saying. He said he was trained to do things in that way. He was trained to improve images and to manipulate the images, and he did not know at the time that these were things that were wrong. At least this is what he claims. Let me say a couple of words on conflict of interest. Well, these are situations in which your knowledge on certain people and on certain circumstances might influence your judgment, might influence their behavior, but they always existing. If you don't have a conflict of interest, probably it means you don't know much about the thing that you are being asked to evaluate. So there's always some distant or close conflicts of interest, and the only thing here is you have to handle them properly. You have to declare and you have to seek advice. If you think you might have a conflict of interest, you have to raise your hand and tell to the chair of the committee, well, I know this person for this, this, and this, or I've been publishing with that person. I have a common project with that person. This might influence my judgment. And then the chair will decide whether you remain in the room, whether you have to leave the room or you have to leave the chair. How common is the misconduct? Well, in 2005, Nature published, and they found a very high figure. They said that 1 every 3 scientists they were confessing to have committed research misconduct, all types of research misconduct. And that includes inventing data, and that includes removing outliers. So minimally considering research misconduct and artificially cheating and manipulating and fabricating data. Well, in 2018, Retraction Watch was releasing their database of more than 18,000 articles. Well, nowadays this number is higher, and they were releasing some statistics, and that was very interesting because you will see these are the countries in which the retraction rates are higher, and you might have some misconceptions. You might think that some countries they will be in the first positions, and you will be surprised to find some countries that are usually selected as an example of research integrity, but here they are shown also very high in the list of countries with researchers with retracted papers. And for instance, on the list of the topmost retracted authors, again, there is always this misconception with some countries, and you will be surprised that there is a Japanese researcher at the top of the list with more than 169 papers being retracted. And you can follow and you can reach the entire list. So be aware that retraction is happening and research misconduct is happening all across in different countries. The best, to my knowledge, study on research misconduct and on the figures and the percentages and how this is affecting research community is this work by Danielle Fanelli. And she was doing a meta-analysis, and the power and the significance of this study is that she was combining 21 studies. And these were the findings of Danielle Fanelli. 72%, that means 3 every 4 people, observe questionable research practices by other colleagues at least once. That means I observed someone removing an outlier. 3 out of 4. 40% observe fabrication or falsification. Well, this is a very high percentage. 40% of people observe things doing wrong by colleagues around them. What about yourself? 34%, again, the same figure as was put by Nature years ago. 1 in 3, 34% admit they have done questionable research practices. And then last but not least, this is the most important figure for me, 2% have admitted fabrication and falsification. I don't know whether this number is strictly correct. I don't know whether this is 2.5 or 1.5 or 3.5. What I do know that this is not zero. And this is the message I want to convey. So there are certain people in every single institution that they will try to find a shortcut. They will try to do research misconduct. This is unavoidable. This is because we are human beings and we commit mistakes, and there's always people trying to not follow the guidelines. We need to increase our training efforts. We need to increase our detection efforts in order to detect as soon as possible this research misconduct and remove these results and remove these people from the research community. So my final message is, please try to be a good person, try to be a good citizen, and you most likely will be a very good researcher. So you find myself, this is my webpage and this is my email, and I'm more than happy to respond to any of your questions. So thank you for your attention.
Thank you very much, Professor Luis. Yes, we have indeed in our chat few questions.
Okay, I will open the chat. So this is, well, you let me know. So
yes, I could read the first one is a bit longer, but I will read it for you. In academic publishing, there is a huge pressure and also the phenomenon of overpublishing because of the scientific metrics, requirements, etc. A new study shows that the number of papers is increasing faster than the number of PhD graduates. This also contributes to a lot of falsification, misconduct, etc. Also, the high amount of money you have to pay for an open publishing sometimes is ridiculous and also increase the gap between scientists coming from different socioeconomic backgrounds and reproduces the science social inequalities. So I think this and other systemic problems are highly contributing to different misconducts, unethical behaviors, and so on. How do you see this trend going on in the future, and what are your ideas about creating a more inclusive publishing and coding of on a system level and on personal level too, as researchers who have to publish? I am coming from the field of sociology. Thank you very much.
thank you, Russo. I couldn't agree more with your thoughts. This is probably the problem we have nowadays and since many years in the research community. I'm a bit pessimistic regarding the future, but I only see one exit. I only see one solution, and the solution should be open science. The solution should be that we should agree on a system where we can publish freely and we can let the readers read freely. This is the diamond concept. The diamond concept is that I do not have to pay to publish. I do not have to pay to read the articles. And this is where I wish we will be in the near future. And of course, I'm not an idealistic, I'm not an utopic. So publication has some inherent cost, but this cost should be absorbed by the institutions. The institutions that they're doing research, they should be covering this cost. And this cost, they can be brought down to the minimum because we're talking mostly about online publication. We're not talking about publishing in press. We're talking about online publications. Whatever these costs they could be, what is unacceptable today is that there's some publishers, they are making profits in the range of 30 or 40%. Well, not even Amazon, not even Google is making these profits. Most of the large companies, they're having profits in the range of 3 to 5%. So this is absolutely unacceptable, what we are paying. So the way to go to move forward is first open science, creating journals that people can submit freely without having to pay, and the papers are being analyzed, and according to the excellence, they are eventually being published. And in second place, these papers, they are freely accessible to anyone because it is unacceptable that you have to pay for reading the results from other people, particularly when this research is being done with public money.
Thank you. And the next question is from Teodora Laguri, and she would like to ask you, could you share your thoughts on the current use of AI tools in writing scientific papers?
Well, this is a challenge. This is a reality. Well, we can discuss at length this issue, but the reality this is already happening. You know that there are systems to detect whether artificial intelligence has been used in order to prepare a text. We need to be aware that this is something that can be easily detected. There are some systems better than others, but in reality, because they're using some algorithms, so you can use another algorithm to detect whether AI has been used. So I would put two different cases here. For instance, I have Spanish as my mother language. I'm not a native English speaker. When I write my articles in English, I try to do my best. And normally what I did in the past, I was sending these articles either to a scientific English editor or to a friend. Normally it was a colleague who was reviewing my paper and was telling you, well, maybe you should be changing this phrase because this is not properly being written. Well, fine. Now I can use ChatGPT or you can use any other system in order to review the quality of your English. And this is acceptable. I believe this is similar to what we did before, but now is a machine which is reviewing. But the text has been created by you. The results have been created by you. Something totally different is telling your AI, please produce a graphic between two series of data in which there are 10 samples in each series, in which the difference is about 30%, and which is statistically significant at the level of 0.005. And the machine will create the data. And this data, it's impossible to detect that they are wrong because the data will be right. But you will be creating, you will be cheating, and you will be using this, and you might even create a text that will describe this non-existing and never performed experiment. Well, this is wrong. And this is creating fraud. And now this is making fraud more easily and more rapidly. And we should be aware that AI has come here to help and has a lot of very good benefits. And we should try to use this responsibly. Whereas the misuse of the AI in order to cheat, in order to create experiments that we haven't done, well, this is what should be denounced and this is what should be neglected and discarded.
Thank you. The next question from Pankaj Mitrosa. I'm sorry if I pronounce your name wrong. Could you share your insight on the PhD students' research misconduct identified on laboratory experiments which are not published in journals? Does that constitute a misconduct or lack of training?
Well, if the problem, as I said at the beginning of my webinar, was the research record, the responsibility you hold when you leave behind something that is wrong. Because people coming later on will be basing their future research on what you have been already communicating. So you're crossing a red line when you are publishing in a journal something that is inherently wrong. When you're doing some of these behaviors in your lab, and this is detected before going anywhere else, well, this is probably a very good excuse to take this person to a training course and to let this person know that this is something unacceptable. And probably this will be a lesson this person will never forget in the rest of their research career. And this will be a good opportunity, not only to teach this person, but also to teach the rest of the group about things that you shouldn't be doing. And I always take it positively. As I said, we are human beings. We are exposed to commit mistakes. We are exposed to try to find shortcuts. But whenever this is done, perhaps even naively, I accept that sometimes, as Olivier Boinet was saying, I didn't know that I couldn't do this. Well, now you know. Now you know that you should not be improving your images by removing outliers and making things different, things that are not different. This is wrong. And the next time you do an experiment, you take into account all the samples on your series of data, and please do not remove any outlier. So this can be an opportunity for training. I take it positively.
Thank you. I open the floor if there is somebody online that would like to ask any question. We are over time already 12 minutes, but for a last question to give the floor to the ones that still haven't. No?
I hope this webinar was fulfilling your expectations on the topic.
Yes, on my side, yes. I believe for the rest as well, very interesting, and thank you very much. On the last note, you said that in Spain in 2015 they're starting the talks about these ethical issues, but only in 2023 the first committee of research integrity have been set. In your opinion, why it took so long, and have been there any factor behind it that in 2023 this happened? Thank you.
Well, this is a very good observation, and I'm asking myself why my government took 8 years to move from a national declaration, and actually it's not even 8 years, it's more years, because we had a law of science, a national law of science that was issued in 2011, and that law was already creating that committee, but this committee was never created. This committee we were hoping and we were waiting from a governmental mandate in order to create that committee, and that committee was never created. So politically, it was not considered appropriate to create this committee. I don't know why. And the reality is that because the committee was not created, from the universities, the scientific societies, and from the CSIC, which is the largest research institution, we put forward this national declaration on research integrity to have at least one very small agreement that we all could share. And that was issued in 2015. And later on, the law of science was updated in 2022, and that was updating the necessity to create this committee. And eventually this committee took place and was created in November 23. I mean, I would have liked to have this committee earlier, but again, I'm taking this optimistically, and I'm happy that now we have such a committee in place.
Thank you. Thank you very much. I see many comments of thank you, and that's
Oh, yes, I see.
positive.
Thank you. Yeah, you are very kind.
So I believe this is the assessment that the presentation that you have made was
Thank you.
very interesting for all. And we would like to thank you once again for your time and participation in our webinars. Thank you very much, and thank you to the rest of the participants. We are looking forward to have you during our next webinars. Thank you, and
Thank you, Mariana. Please keep me informed about whenever you will be releasing this recording and etc. And I